In today's video, I'm going to introduce the definition of redox reactions in 3 ways and bring up 2 applications toward this topic. The definition of oxidation-reduction reactions is the chemical reactions involving oxygen. It is probably what you learned in high school chemistry. For example, the reaction of iron oxide and carbon monoxide. Apparently, you can identify that carbon monoxide gains oxygen and becomes carbon dioxide. So, we can refer to carbon monoxide as the reducing agent. To further elaborate on the concept, we can then define the reaction as the transfer of electrons between reactants. In terms of that, the substance that loses electrons is said to be oxidized. Let's use the same equation to verify. These 2 equations are the half reactions of iron oxide and carbon monoxide. On the second equation, it indicates that each carbon loses 2 electrons. Given that oxidation implies the loss of electrons, we can conclude that the carbon ions with the charge of 2+ are being oxidized and serve as the reducing agent. It's the same situation on the other side. The other species experiencing the opposite reaction, so it gains electrons and undergo reduction reactions and being as the oxidizing agent. The next definition is the most comprehensive way to identify the reaction. It is to determine the conclusion by considering the oxidation state of each substance individually. So what is oxidation state? To take these molecules for instance, the oxidation number of carbon in the compound can be calculated as following, and thus we know the answer is 0 to the oxidation state of carbon in this molecule. But why can't we refer to the value of oxidation state as +1 and -2 for hydrogen and oxygen respectively? There are certain rules for assigning oxidation state shown in the following sheet. Just to bear in mind that when assigning the oxidation number, you have to follow these rules in order. For atoms not covered by the rules above, their oxidation state are calculated by balancing the equation as the sum of oxidation state of the compound equal to its charge. In summary, the loss of electrons corresponds to the increase in oxidation number. So substances that experiencing the decrease in oxidation number are reduced. And from the opposite side, it is being oxidized. This method provides the most accurate means of identification of oxidizing and reducing agents. And here are some examples to manifest the procedures. The first one starts with the oxidation state of calcium. The value is +2 based on the rule 4 that we mentioned before. For the group 2, its oxidation state have to be +2. The oxidation number of remaining atoms can be calculated as following, as the sum of the value for the molecule equals to 0. And then we can compute the answer as -1. The second one has both oxygen and hydrogen. But just as we mentioned before, oxygen takes the higher priority in assigning oxidation number due to the larger electronegativity. And according to the rule, oxygen is written as -2. As for hydrogen, the value is +1 because the sum of the oxidation state is 0, just like the first example. So we can refer to the answer as +1. And the last one had 3 elements in the compound. We also need to bear in mind that the oxidation number should be assigned in order. So it should be first the oxygen and then the hydrogen. So follow the rule as we mentioned before. We can conclude the answer to +3. Actually, almost everything that happens in our daily lives has something to do with redox reactions. One prominent application in recent years is the fuel cell. The reaction occurring on the anode and cathode are the half reactions of the overall reaction. A schematic diagram is shown with the equations. So this process can be classified as redox reactions. For the negative electrode losing the electrons, is defined as reducing agent, and the positive electrode is oxidizing agent. The next application is vitamin C. This is the antioxidant that can protect the cell from being damaged by the free radicals in our body. So the so-called free radicals, it have an uneven number of electrons, carry the charge which make it highly reactive to other molecules. And vitamin C is served as the reducing agent, donating the electrons to stabilize the free radicals. So we can see in these diagrams, vitamin C will donate the electrons to the free radicals, making it more stable because all the vacancy is being occupied. Due to the multi-resonance structure, it won't be the next free radicals. So after donating electrons, the negative charge is stabilized. The negative charge will on the oxygen, and the resonance structure make it jump to other atoms to form these second structures, and then further jump to other oxygens. So it has 3 different structures, make it more stable because the localize of the charge. The structure is stable because it spreads energy over the large area. This is the end of the brief introduction. You can find the exercise for the assignment of oxidation state attached to this video. Thanks for your watching.